In this video, we're gonna do some practice on limits, and these questions are advanced. So let's say you have a piecewise function, x plus 1 and x squared. The first piece is when x is smaller than or equal to a, and x squared when x is bigger than a. They told you here f is continuous on minus infinity plus infinity. It means continuous everywhere. Now, using this fact, we're gonna check what we need to have. We might have problem at a, this number, because I know that x plus 1 is a straight line. It's continuous everywhere. X squared is a quadratic function, so it's continuous everywhere on minus infinity plus infinity. But let's check, because we have two pieces, what's happening at a. Limit as x approaches a minus. When we're approaching from the left side, it means I'm talking about the first piece of the function, and simply replace a. So you get a plus 1. Now, limit as x approaches a plus, it means we're talking about the second piece. So when it's bigger than a, it means we're talking about x squared, so it's a squared. Because our function is continuous, these two limits must be equal. So I say a squared equals a plus 1, which is a squared minus a minus 1 equals 0. And we solve for a. Either you use calculator or you find delta. It's gonna be negative 1 squared minus 4 times 1 times negative 1. And we get 5, which is positive, so we have two answers. The first one is minus b minus radical delta over 2a. The other one is minus b plus radical delta over 2a. So when you substitute the values, we write minus minus 1, so b is minus 1, this one here. So plus 1 minus radical of 5 over 2a. 2 times 1, a is the coefficient of a squared. So it's 1 minus radical 5 over 2. The other one is 1 plus radical 5 over 2. Now, number 2. Limit as x approaches 0 of 2x minus 1 minus 2x plus 1 over x. Whenever you see absolute value, it means it's a piecewise function. Now, limit as x approaches 0 from the left, it means we're talking about the negative side, or 0 minus. Let's check what happens to this 2x minus 1. Now, imagine you are substituting 0 minus, or like minus 0.0001, or replacing 0 by itself. You will get inside a negative answer. Now, whenever the inside is negative, then this can be written as minus, and you remove the absolute value, you write 2x minus 1. What is the reason of this? The absolute value is something that is positive. So I know that this is negative. So I multiply by negative, so minus minus will give you the positive answer at the end. But just you can always use this. If the inside is negative, you write minus, remove the absolute value, and write what is inside. Now, what about the 2x plus 1? If you replace 0 there, or 0 minus, in all cases you're gonna get a positive answer inside. So this goes out as it is, 2x plus 1. Now, what about 0 plus? If I check 0 plus of this, again, when you replace 0 inside, you'll get negative answer. So again, it will be this. And for this one, we're gonna get positive answer in all cases, so just remove the absolute value. Now, to find the limit as x approaches 0, in both cases the 2x minus 1 will become minus 2x minus 1. So I will write instead of it minus 2x minus 1, and the other one just remove the absolute value and write it parentheses. Let's distribute and evaluate. Clearly these will cancel, so you get limit as x approaches 0 of negative 4x over x. When you cancel, you'll get minus 4. Let's check this question. Limit as x approaches 0 of radical ax plus b minus 2 over x. They told you it's equal to 1, so we need to find a and b. Now whenever I have radical, I should start by doing the conjugate. So I multiply the numerator by its conjugate, which is ax plus b in the radical plus 2, and I do the same thing down. Radical of ax plus b plus 2. When you simplify the numerator, it will be ax plus b minus 4, and down you will have this. I know that my answer will be 1 at the end. Now I'm gonna do the following. So because I know that my answer is gonna be 1, it means the limit of this exists. So because it's equal to 1, it means the limit exists and it is equal to a number. It is finite. So it's not infinity. Now I'm gonna separate this in this way. I will take the term with x alone, plus the limit as x approaches 0 of the other part alone. Now you are allowed to separate a fraction, if you remember. And if I have x plus 2 over 5, I can write it as x over 5 alone plus 2 over 5 alone. And this is what I did. I took ax alone and b minus 4 alone. Now, for the first one, clearly, the x and the x will cancel. So I get limit as x approaches 0 of a over radical ax plus b plus 2. And for the other one, I cannot cancel anything. Now, I know my answer will be 1 at the end. So for this one, if you tell me, okay, here it's gonna be something, a number, for this as a number over 0, it's wrong, because I know the limit at the end will not be infinity, because number over 0 will give you infinity. So it doesn't work. Now, what I know that for the first one, this will be equal to 1, and for this one, it's gonna be the whole thing, the limit, all of it will be 0. Because there's no other way to do it. The b minus 4 cannot be a number over 0. It means the whole thing here is gonna be 0. Now, if fraction is equal to 0, or the limit here is equal to 0, it means the numerator is 0. So when I say all of this is equal to 0, now we don't do cross multiplication, just fraction equal to 0, it means the numerator is 0. So b minus 4 equals 0, it means b equals 4. So I found b. And for this one, I want the limit as x approaches 0. So let's substitute instead of x 0. I will get radical of 0 plus b, which is b, plus 2. I know that this one is gonna be 1. So at the end, our answer will be 1 plus 0, which is 1. Now replacing b by 4, you get a radical 4 plus 2 equals 1. So a over 4 equals 1. Cross multiply, and a will be 4. So a and b here are equal, and they are equal to 4. Now let's check One more question. Limit as x approaches 0 of sine 3x over sine 4x. Now we know that limit as x approaches 0 of sine x over x is equal to 1. So I'm going to use this idea. Limit as x approaches 0 of sine 3x. Now what I need to do is to divide here by x and divide the denominator by x. This is the first step. Why I can do this? Because if you have fraction over fraction, you are allowed to cancel the denominators. So you go back to sine 3x over sine of 4x. So this is basically the same thing as the one above. So if you divide by x on top and down, it means you didn't change the question. Now remember, I should have here the same thing here and here. But here I have 3x and down I have x. So I cannot conclude that the first or the numerator is equal to 1. It doesn't work. So what you need to do is you multiply the denominator by 3. So you make it 3x. But you should multiply the numerator by 3 as if you are multiplying by 1. Yani 3 over 3 is just like 1. And for the one down we have 4x. So I need 4x in the denominator. So I multiply the denominator by 4 and the numerator by 4. Now I evaluate the limit. I know that limit as x approaches 0 of this one is equal to 1 because of this rule. So limit as x approaches 0 of sine of u over u is equal to 1. Anything here should be the same. So we get 3 for the numerator times 1, and down we get 4 times also this one because we have same thing up and down, or inside the u, inside the sign I mean, over the denominator which is the same. So also 1. So my answer here will be 3 over 4. I'll do one more question. Limit as x approaches 0 of 1 minus cosine of x over x. Now, if they tell you in the question here, near 0, so near x equals 0, for very small values of x if you want. It's given to you that sine of x is almost equal to x. Then we're going to use this fact after by showing that 1 minus cosine of x over x is equal to sine squared x over x plus 1 cosine of x. Now, this was given as a hint. So let's try to prove it. 1 minus cosine of x over x. I start to get anything related to sine. I need to multiply by 1 plus cosine of x as if you are multiplying by the conjugate. So you get 1 squared minus cosine squared of x. I'm using this rule, a minus b, a plus b, which is a squared minus b squared over x 1 plus cosine of x. Now 1 minus cosine squared of x in the numerator, that will change to sine squared of x. These are trigonometric identities that you should know. Alright, so our limit as x approaches 0 of 1 minus cosine of x over x is the same thing as doing limit as x approaches 0 of sine squared of x over x1 plus cosine of x. Now, since we know around 0 or as x approaches 0, the sine of x is the same as x, almost. So the limit as x approaches 0, I will replace sine by x and I will evaluate later on. X and x squared, they cancel, we get x exponent 1. So limit as x approaches 0 of x over 1 plus cosine of x, we get 0 over 1 plus cosine of 0. So 0 over 2, which is 0.